Welcome to The Explainer. Today, we're going to crack open the AI Architect's Handbook. We're going to get into the core ideas that separate a simple AI prototype from a powerful production-grade system that, millions of people can actually rely on. So how are these incredibly powerful AI tools we use every single day actually built? Well, spoiler alert, it's not about just picking the biggest, baddest model off the shelf. No, it's about really sophisticated design, elegant trade-offs, and building something that's not going to break. And that, right there, is the job of the AI architect. Okay, so let's dive right into this. And we're going to start by understanding the core conflict, the main headache that every single architect has to deal with. It's a classic problem in engineering, but with AI, it just takes on a whole new level of complexity. And here it is, the unbreakable rule. The triangle of cost, latency, which is just a fancy word for speed, and quality. An architect's job, their entire job, is to master the trade-offs between these three. So for example, let's say you need a customer support bot that's super fast and cheap. Well, you're probably going to have to sacrifice some quality. But if top-notch quality is what you absolutely need, well, you're going to pay for it, either in dollars or in how long it takes to get an answer. So how do they actually solve this puzzle? I mean, it seems impossible, right? Well, architects don't just guess. They rely on these really powerful mental models that act like a compass, guiding every single decision they make. So, the first rule in the handbook is this. Choose the right tool for the job, not necessarily the biggest or the most expensive one. I mean, think about it. Using a massive cutting-edge model to just, classify simple customer emails, that's like using a sledgehammer to crack a nut. It's a total waste. A good architect finds the perfect fit. Now, this next one, this is a huge mindset shift. Great architects, they don't just plan for everything to go right. They actually obsess over what could go wrong. They build their systems assuming the model will hallucinate. Just make things up. They assume that latency will spike or that some user is going to try to hijack the prompt with some crazy input. They design the safety features for these failures from day one. And this quote just brilliantly sums up that whole mindset. It's this proactive, you could almost say pessimistic way of thinking that you absolutely need to build AI that is not just powerful, but actually reliable and safe out there in the real world. So what are the actual building blocks that an architect works with? Let's peel back the layers and look at the anatomy of a modern AI system. You see, a system isn't just the model. It has all these different layers, and each one has its own set of challenges. You start with the data layer, where you're worried about freshness and quality. Then there's the model layer, where you manage different versions, all the way up to the governance layer, which is what makes sure the system is safe and fair. The architect has to be a master of all of them. And when they're tackling a brand new problem, they don't just start writing code. They follow a very structured framework, kind of like this one. First, they define what success even looks like. Then they get the data figured out, choose the right approach, and this is crucial, they plan how the system is going to learn and get better over time, all while keeping a close eye on that total cost. Okay, now let's see how all these principles actually apply to one of the most critical, most common decisions every AI team has to face today. This is the classic problem, right? You've got this powerful general model, but it knows absolutely nothing about your company's internal documents, your products, your customers, nothing. So this question leads to a huge fork in the road. Do you have it retrieve information as it needs it, or do you actually retrain the model itself? So on one side, you have retrieval augmented generation, or RAG. Just think of this like giving the AI an open book test. It looks up fresh info right before it gives you an answer. Then on the other hand, you've got fine-tuning. This is more like sending the AI to a specialized training course. It doesn't just learn what to say, it learns how to say it to adopt a specific personality or a certain style. So, RAG is for facts that change, and fine-tuning is for a voice that needs to stay consistent. And here is the most important point. This is not a competition. It's not RAG versus fine-tuning. A smart architect knows it's about using the right tool for the right purpose. In fact, the most sophisticated systems out there, they often use both. They'll fine-tune a model so it speaks in the company's voice, and then they'll use RAG to give it access to all the latest product information. So, what really separates that cool prototype you built over a weekend from a tough, production-grade system that can serve millions of people? Well, it really comes down to two things: cost and safety. Look, you can build the most brilliant AI in the world, but if it costs a fortune to run, or if it can be easily tricked into saying harmful things, it's a failure. It's dead in the water. An architect has to be aggressively managing both of these from day one if they want to build something that lasts and that people can trust.
So here's a great example. A relatively simple technique can have a massive impact on cost. It's called semantic caching. Basically, instead of paying your expensive model to answer, "What are your business hours?" 1,000 different times, you answer it once and you store or cache that answer. Just doing that can slash your costs by an average of 40%. It's huge.
And this is even more powerful. Instead of just sending every single question to your most expensive model, you build a smart router. A tiny, super cheap model handles the simple stuff, and only the really complex questions get sent up to the powerhouse model. By doing this, architects can see these massive, massive savings without sacrificing quality where it really counts. Now, on the safety side, it is all about multi-layer defenses. Architects build what are called guardrails. They'll have input guardrails that inspect incoming prompts for attacks, and then they'll have output guardrails that check the AI's answer for hallucinations or toxic stuff before it ever reaches a user. It's like building a digital immune system for the AI.
So, after all of this, what's the ultimate takeaway? What is the core, the true essence of the AI architect's job?
There's this really common misconception that better AI just means a bigger, more powerful, and way more expensive model. That's a brute force approach, and it's almost never the right one for a real-world product. The real genius, the true art of AI architecture, lies in all of those deliberate, thoughtful, strategic decisions. It's that balancing act between cost, speed, and quality. It's knowing when to use a small model, how to cache things smartly, and how to build systems that are safe and resilient. So the next time you interact with an AI, just take a second and think about the invisible trade-offs that made it possible. Because behind every seamless chat, behind every instant answer, there's an architect's blueprint, a complex web of choices, all balanced perfectly to create an experience that just works.